Recorded is rolling. It's Thursday, February 26th. We're going to pick up where we left off yesterday, going through SAT math solutions. So you guys know SAT is next week. All 11th graders are taking it. So if you're a junior, you're going to take probably March 5th, but if you're EFSC student, then March 6th. Right? And if you're not taking it at all, which might be a couple of guys, one of your classes might possibly be relocated. So that information is also all in the same Excel file. The SAT math is in 2 modules. Collectively, it's 70 minutes to do 54 questions. So a good rule of thumb is you have a little bit more than 1 minute per question. To pace yourselves there. Okay, you guys did this infrastructure trial and fifth period. Okay, make sure everybody can get on Blue Book. Okay. Oh, and your physics, fluid dynamics quizzes are returned to your folders. So you guys can have those back. Okay, so let's see here. Yeah, yesterday we did this question with the candles, right? I put that in right for the bell. So that's on yesterday's video. Let's move it on here. We got these 2 inequalities. Here, I'll write these down. So this shows up better on the video. We got y is less than or equal to x plus 7. And we got y is greater than or equal to negative 2x minus 1. Okay. So we got the system of inequalities. And they're saying which point xy coordinate is a solution to, well, the system, right? Now, there might be many possible solutions, but I guess out of those multiple choice answers, there's only one that works. Okay. Now, I think probably the fastest way to go through this would be to play off the choices. Guys, could you just do this? Could you pick option A and then plug it in and see if it is valid for both of these and so on and just move down? That's probably the fastest way to do this. Okay, let's try at least one of those. How about C? Let's say you start with C. I like positive numbers. Okay, so 0, 14. See if that works. So first equation. If I plug in 0 for x and 14 for y, is 14 less than 0 plus 7? No. So C immediately failed. So you cross that out. Right? Okay, you can do that one by one. Yeah, it's probably the fastest way. I like to just graph it anyway. So y equals x plus 7. 1, 2, 3, 4, 5, 6, 7. Could be 7, y, x. Okay. Okay, what's the slope of this line? 1. It's like 1x. Right. So this would be back at negative 7. Okay. All right. So this first line looks like this. Okay. And less than or equal to means it could be on that line or it could be underneath the line. Is that true? Yeah. So we're down here. Okay. Now I don't want to shade anything yet because I still got the second one. So greater than or equal to negative 2x minus 1. Well, here's minus 1. Okay. Now, negative 2x. That has a slope of, let's see, up to back 1 here. See, up to back 1 again. Okay, it's kind of go off in that direction. Okay. So this is roughly what this looks like. Okay. There's the second one. And, greater than or equal to that line. So under this line, over this line, couldn't it be anywhere in here? Anywhere in here, right? What do you guys think? Right there. Guys, is 0, 0? Is that a possible solution? 0, 0?
Yeah.
Yeah, that's part of the shaded region. It just made it. If I plug in 0, is 0 less than 7? Yeah. Is 0 greater than negative 1? Yes and yes. Right. No, that's not one of their options though. How about now that I'm looking at it? Guys, how about option D? Do you guys see 14, 0? Isn't that like way the heck over here? 14, 0? That's definitely a shaded region, isn't it? Okay. So let me get my answer key, but I think the answer is D. That's what this is 22. Yeah, the answer is D. D, which is like this point right here. Right, so you guys good with 22 is D? 22 is D. All right, 23. All right, we got weight and frequency. Frequency table summarizes data set of the weights to the nearest pound of 71 tortoises. A weight of 39 pounds is added to the original data set. Now pause right there, because that's actually pretty weird. Right, we got 12 tortoises that are 13 pounds, right? And then you increase a pound and got all these different tortoises. Right? We got 7 tortoises that are 20 pounds. Right? That's really big. Okay? And then we're going to add another tortoise. And this guy's 39 pounds? Wow, he's almost like twice as heavy as the already heaviest set of tortoises. Okay, so it's kind of an outlier. Creating a new set of data of weights for each nearest pound of 72 tortoises. So 72 tortoises. Which statement best compares the mean and the median of the new data set to the mean and median of the original? Right. We'll start with mean. Because mean, don't you just add up all the tortoise weights and divide by how many tortoises? Right. And if we just added a really, really heavy guy to the set, what happened to the mean necessarily?
Increases.
Yeah, definitely increase. Are you guys okay with the mean had to increase? Now the median's a little trickier. Right? Oh, here, let me give you a little side story. So one place that median is often applied is to salary. Right? So what if all of a sudden here we're making like I don't know, like $50,000 a year, right? Right, and then like a super rich billionaire walks into the room. You say, okay, well, the mean salary just increased by some crazy number, right? But what happened to the median?
Okay.
Didn't move at all because median is like the middle value, isn't it? Middle value, and like the middle value, well, that didn't actually change, right? So we might have a similar scenario here. Let's find the middle of the turtle, which would be like the what's that 37th turtle, maybe something like that, like 71 over 2-ish. Right? Let's find that. Let's add these numbers until we get to about 37. So 12 plus 8 plus 5 plus 7. Let's see where we are. Ooh, not quite there yet. So here we're up to 32 turtles. And if I add plus 9, now we've passed the median value. You see that? And if you go from 71 turtles to 72 turtles, it's still in this group of turtles that each weigh 17 pounds. So the median used to be 17 pounds. And after you add the big guy, the median is still 17 pounds. You see it? So it didn't actually change. All right. Let's see what's the answer here. 23. Okay, my key is saying B. Let's see if this corresponds to what I just said. B says the mean of the new data is greater than before. Yep. And the median is the same. Aha! It is B. Okay. Are you guys okay with 23 is B? Okay. So again, to recap, the mean, you add up all the values and divide by the number in the set. The median is the middle value. Okay. And if you have a bunch of turtles in this case that all weigh the same, then in this case, the median didn't even change. Okay, number 24. What is this? I'm going to write this down. 24. They're telling us x minus 29 is equal to x minus a, and then x minus 29. Okay. So we got this. It says, which of the following are solutions to the given equation where a is a constant and also greater than 30? Okay, so you give us 1, 2, 3, and it might be one or multiple of those. Okay, so let's try this. Okay, let's go through one by one. So here are our candidates. Solutions. Okay, so x could equal, and here are our candidates. We have a plus 1, and 29. Okay, so what I would do is I would test out these one by one, and if something's wrong, I would eliminate it. And if it works, I'll keep it. Okay, so let's try a. So that would be a minus 29 equals a minus a. Yeah, there I get. And then a minus 29. Okay. If I plug in a for x, doesn't it make that statement right there?
Yeah.
Right. Now, is that valid? Yes or no?
No.
Yeah. Well, okay. Well, what's kind of wrong with this?
A minus a turns into 0, and that gets multiplied by a.
Yeah. This part right here is 0, and 0 times anything is, well, it's not a non-zero number. Okay. So I think that actually does not work. Does not work. Right. If you weren't paying real close attention, then at a glance, like, okay, yeah, that's fine. But no, that doesn't actually work because 0 times something is not a non-zero number. Remember, a has to be at least 30. So, okay. So we're going to throw this one out. Let's try a plus 1. What if I plug that in? Let's do a plus 1 minus 29 equals a plus 1 minus a times a minus 29. Okay, well, that's a little weird. I'm going to clean this up a little bit. Whoops. Sorry. I missed the plus 1 here. Is that okay? Can I just do plus 1 right there? Is that right? Okay. I'm going to clean this up. Okay, so this will be a minus 28. Guys, what's all this right here? 1. And what's this right here? Is that also a minus 28?
Yeah.
Is a minus 28 equal to 1 times a minus 28?
Yeah.
Yeah. Bing! That one works. Okay, so this one's good. Okay, let's try 29. So 29 minus 29 equals 29 minus a, 29 minus 29. Okay, so 0 equals something times 0. Is 0 equal to 0? Yeah, I'm pretty sure that one should work too. Bing. So is there option 2 and 3? That looks like option C. 24C. Let me make sure. Here's my key. 24. Yeah, 24C. 24C. Okay. You guys got a 24C? All right, 25. In the xy plane of graph of this equation. Ooh, is that equation right there? What basic shape is that? That is a parabola. Got an x squared, got an x, got a constant. Yeah, that's a parabola. Intersects the line y equals c. Okay, what does that graph look like? Y equals c.
Why is that good?
Yeah, there's just a flat line, isn't it? Flat horizontal line at whatever value c is. Okay. At exactly 1 point. Oh, that is a question. What is c? Intersects at 1 point. Guys, if it's a parabola and it crosses a horizontal line at 1 point, what point are we talking about on the parabola?
-1.
Good guess. The vertex. Yeah, the vertex. Here, I'm gonna draw this out. 25. Okay. So, okay, so on some graph, you have some parabola. I don't know if this parabola looks exactly like that, but just to get the idea across. Okay. Okay. Draw some horizontal lines here. So I think most of you guys are imagining this, but I want to make sure everybody has the same picture in their mind. Okay. Let's say I have some different horizontal lines crossing through this parabola. Okay. Now, horizontal line, either it's not going to cross the parabola at all. That could be like if it was way down here. Or usually it crosses it twice, doesn't it? If it crosses it, it's going to cross it twice. With one exception. And that one exception is if it hits it right at the vertex, and then it only hits it once. Okay. So this is a vertex question. Did we have a vertex question yesterday? Vertex? Yeah. Okay. Yeah, because I got different classes and different packets, so I forget exactly. But because vertex of a parabola is a question that I've seen come up over and over and over on SAT math. So guys, this right here, what I'm about to write, will pick you up points on the SAT. So everybody's definitely taking notes right now, right? Okay. So if you have a parabola in the form y equals ax squared plus bx plus c, yeah, like some parabola. This x vertex is always at whatever what? Huh?
Something b equal 2a.
Yeah, negative b over 2a. Every day. Okay. Guys, what I'm circling right now, you guys see what I'm circling? Know that before you go into the SAT, and you will get points, including what we're doing right now. And so we got the equation y equals negative x squared plus 9x minus 100. Okay. And since we know, we reason, okay, well, they must be talking about the vertex. Then let's find x vertex, which is at, okay, negative b, that'd be like negative 9 over 2. And then, guys, what's my a value? Negative 1. Okay. So the negatives cancel. I think that's 4.5, isn't it? Okay. Now that's the x value. Okay. If I wanted to find the y value, how would I get the y value?
Plug it back.
Yeah, plug 4.5 into this x, and then I could find y that way. What was the what? Actually, we do have to do that. Yes, we do have to do that because they're saying y equals c. So we're trying to find the value of this horizontal line, which is the y value, isn't it? So that's it. Let's do c equals negative. Okay, we got 4.5. We're gonna square. Go 9 times 4.5, and then minus 100. So whatever this is should be the answer. Is that okay? You guys follow that process? A lot of little steps. All right, so let's go negative, and then 4.5 is being squared. Then plus 9 times 4.5, and then minus 100. Okay, so I'm getting negative 79.75. And I do see that in their answer choices, they have a lot of fractions. So guys, if you see 0.75, it's like, I want to make this a fraction. I should really multiply by what? Multiply by, let's go 4. Right? And this is negative 319 divided by 4. Okay. Because I took this and multiplied by 4, and I got 319. Therefore, 319 divided by 4. Okay.
Wait.
Okay. That should be the answer right there. And I do see that's a multiple choice answer, which is C. So I'm going to double check on the key and make sure the answer is C. That's 25. Yes, 25 is C. 25 is C, which is that right there. That's exactly it. Okay. This picture is an abstract general representation because that's definitely not a negative y value, but you guys get the idea. Okay. Okay. All right, you guys ready for 26? Yep. All right. Here's it. All right. Before I move on, see what I circled? Everybody's going to know that before they go to the SAT? How to find the vertex of a parabola. All right, number 26. We got here. The functions f and g are defined by these equations. Which of the this type question. Okay. Which of the following equations displays as a constant or coefficient the maximum value? Right. I see different versions of this. Sometimes they ask for like a y-intercept, but here we're looking for a maximum value. Okay. Maximum value. Okay. So this equation 1, here, I'm going to write these down so they're bigger. Okay. So we got equation 1 is f of x equals, see, something times 1.25 to the power of x, and the whole thing is plus 41. Okay. Equation 2 is, okay, we got g of x, and that's 9 times, we got 0.73 to the power of x. Okay. Here, let's throw those on a couple set of axes. Let's make some graphs out of this. X-axis, y-axis. We're making it the basic shape. Because if you know the basic shape of these, I think that'll help to answer the question too. Okay. All right. So, so one more detail. I almost missed this. Okay. Oops. You guys see this last detail right at the end? I almost missed that. It says x is greater than or equal to 0. So we're not considering anything in negative territory. We're only talking about positive territory. Is that okay? Right, so let's start with this f of x right here. Guys, if you plug in 0 for x, that can be a good starting point, right? What's 1.25 to the power of 0?
1.
1? 1 times 18 is
18.
18. And what's 18 plus 41 is 59. Okay. So I just found the y-intercept up here at 59. That's 1 point. Okay. And how about if you plug in negative infinity for x? What's 1.25 to the negative infinity?
I mean,
1.25 to the negative 1,000 is 10 to the negative 97. That's 0. It's 0. So this whole bit is 0. So this whole bit, 0 plus 41 is what? 41. So if I put 41 on the board, that's going to represent a horizontal asymptote going to the left. Notice I said negative infinity for x. Okay. All right. Do you guys know what the rest of that curve looks like? Anything to the power of x. That's called a what kind of equation? Starts with an ex.
Exponential.
Exponential, right? Which you don't see very often in this class physics. Right? Not in your physics labs. Right? But yeah, in the real world, these have some applications. It's gonna look like this. Right? So there's the general shape. You guys okay with that's the general shape for f of x? Right, you guys good? Okay. How about this g of x? Well, is this also an exponential equation? Yes. Okay. Here, let's chase down the y-intercept. Guys, who can tell me what's the y-intercept? 9? Because if you plug in 0, 473 is 1 times 9 is 9. Yeah, now that's maybe like way down here. So we got this value 9. Okay? Right. And if what if you plug in 1,000 for x? Hey, guys, this x is getting bigger and bigger. And you take 0.73 to a bigger and bigger value. Overall, what's happening in g of x? Are you sure? It's getting smaller. Guys, 0.73, if you square that, it's getting smaller. Times 0.73, smaller. Smaller. Every time I multiply by 0.73, I'm shrinking it. It's becoming 73% of the previous value. In fact, if I keep hitting enter, like I'm doing, enter, what number is this approaching?
0.
0. And on the graph, that's a what? Horizontal asymptote. Okay, guys, this is basically this curve. here's g of x. Okay, here's f of x, here's g of x. Are you good with f of x and g of x? They're both exponential curves. F of x is exponential growth, g of x is exponential decay. Okay, you guys good? Okay. Now, right at the tail end, detail almost missed. They said x is strictly, well, no, sorry, x is greater than or equal to 0. So we're going to throw out all the negative stuff. So none of this counts. Okay, we're just looking at this right here. Okay, and they said we're trying to find a maximum value. Guys, does f of x have like a quantifiable maximum value, or does it just go to infinity? Yeah, it just goes to infinity. So there's a minimal value here, but not really a maximum that I can point to. Right? Definitely not an equation. Okay. But what about g of x? Does this have a maximum value on the domain that we're interested in?
Yes.
It does. It's right here, and that value is 9. It's 0, 9 as a coordinate. Is that true? It's a maximum value 9. Does that value 9 show up in the equation?
Yeah.
It does right here, and that's what they were asking. They were saying, is there like some number either as a constant or coefficient or some way that could represent the maximum value? And there is for g of x. Right, again, on the specified domain, the maximum value is 9, and it shows up right there. So I think the answer is 2 only. You guys think the answer is 2 only? Mm-hmm. Right. And 26 is B. 26 is B. Yeah, it sure is. Sure is. Okay. Hey, you guys got on 26 is B? All right. And 27. I mean, these last few are pretty tough. So let's see what we got here. The perimeter of an equilateral triangle is 852 centimeters. The 3 vertices of the triangle lie on a circle. The radius of the circle is w root 3 centimeters. What's the value of w? Okay, I would definitely draw this out. Okay, because equilateral triangle means what kind of triangle?
All sides are equal.
Yeah, all sides are equal, and all the angles are how many degrees?
Same.
Yeah, the same, which would be 60 degrees, right? 60-degree angles on. Okay, so they said points lie on a circle, so I'm going to draw a circle. Okay. And then let's get an equilateral triangle. I think this is pretty close, probably close enough for what I'm doing here. Okay. So let's get an equilateral triangle. It's going to be a giant geometry puzzle. You can solve a geometry puzzle. Okay. So we got, okay, you guys go with, that's the setup we're going for? Okay. You guys know each of these angles is 60 degrees right here. 60, 60, 60. All right, so we know all that. They told us the perimeter triangle is 852 centimeters. Okay. They said the radius of the circle.
When did they tell us that?
Right here.
Okay.
852. Okay. So we got 852 centimeters. Okay. And the radius is w root 3 centimeters. So if I put a dot right at the center of the circle, right there, and I draw any radius, how about this radius? That looks pretty good. Okay. This line is equal to w times the root 3. Okay. Right, that right? All right, what's the value of w? All right, so gotta do some trigonometry, do some geometry here. Okay. Now, I think the way I would approach this is draw some more lines here. Let's get some more lines going. Okay. Okay. Those lines are going to be really helpful. Okay. Because now I have a bunch of little triangles. And all these little triangles, well, could have some similarity. Okay. Like you guys, what is this angle right here? 30 degrees. Okay. Yeah, so like 30 degrees here and 30 degrees here to add up to this original 60. Okay. Guys, what is this angle right here?
That's 90, so that's
45. Wait.
Is that has to be 90, so 30 plus 90.
Yeah, okay, yeah. This is 90, this is 30. 60. 60 degrees. Okay. You guys ever heard of a 30, 60, 90 triangle?
Yeah.
Right. And that refers not to the sides, like the 3, 4, 5 triangle refers to the sides. 30, 60, 90 refers to the angles. Okay, 30, 60, 90. Okay. Yeah, and you guys know any flat triangle, the angles have to add up to 180 degrees, so that could be helpful too. Okay. Right. Guys, I'm gonna put this to the side for a moment. You guys got this in your notes so far? You guys got okay. I'm gonna put this aside for a moment. I want to talk about 30, 60, 90 triangles. Okay. There are a lot of puzzles I solved in my life, not even just school stuff, just like my own projects I want to work on, where it's been really, really helpful to know, well, what I'm in the middle of drawing right now. Okay. So let's get a 30, 60, 90 triangle. Draw however you want. Okay. Okay. Guys, if I call one side equal to x, maybe it's 1 inch or whatever it is. Okay. Does anybody know what the length of the hypotenuse is every single time for this particular triangle?
90.
Well, in terms of x, like guys, if this is 1 inch, then how long is the hypotenuse?
That is hypotenuse, so
How close do I get this angle? Do I have a protractor up here? No. Thinking of measuring it out, but
45.
does anybody have a protractor?
45.
There's 1/0.
Yeah, thank you. Thank you. All right. I want to see how close I got this angle, because it's just kind of sketched something out. I don't know if this is accurate. No, you know what? I'm gonna start this over. Okay. I want to draw an accurate triangle. I want you guys to see this is actually true. This is actually true. Try this here. But I wanted to nail this angle exactly. Okay, well, did I get the right angle? Yeah, okay, so I got 90 degrees right there. I just measured it. That's 90 degrees. I want to make this an actually accurate triangle. So from this point, here's 60 degrees right here. Zip this off. Goes up that way. Ooh. Okay, yeah, no, that fits. Okay. And then this should be 30 degrees. I'm gonna confirm that. Make sure this is 30 degrees. Oh yeah! Oh yeah! That is. Okay. Now I have an actually accurate version. That's actually 30 degrees. This is actually 60 degrees. Okay. Let's see, how long are these sides? Let's do some science here. We're doing some science. I want to prove something really awesome to you guys. Ooh, that's exactly 9 centimeters. You guys see exactly 9 centimeters? So I'll call this side exactly 9.0 centimeters. Okay. If that's 9 centimeters, I wonder what the hypotenuse is. You guys ready to see something crazy? You guys just want to see something crazy?
Yes.
Okay. Let's see.
That's 8.
It is! Guys, it's 18, like down to the smidgemeter. It's 18. This right here, this hypotenuse, is 18 centimeters exactly on the nose. Oh. What's the ratio of these two? 2 to 1. It's 2 to 1. Okay. So in general, if this is x, this is always what? 2x. 2x. Okay. And what do you guys think? Does anybody know the side? Well, it has to be longer than this, shorter than this, doesn't it? Okay. Could you do Pythagorean theorem and figure it out? Actually, why not? Let's do it. Let's drop the x, just call x like 1 inch or whatever. Okay. Let's do 2 squared minus 1 squared, because I'm trying to find the other legs, I'm subtracting. And then take the square root. So it's the square root of 3. So it's the square root of 3 times whatever the original x is. Okay. So, guys, if you have a 30, 60, 90 triangle, again, those are angles, then the sides are always the ratio 1 to 2 to the square root of 3. Okay. And like I said, there have been many projects I've worked on in my life where that's been a really helpful fact to know. Okay, so you guys go with that? Okay. Let's see what it is over here. Let me see. If I multiply, what is 9 root 3? It's like 15.58. Right. I wonder if this side is about 15.58. Let's see. Go up here, measure this out. 15.6. Close enough. Yeah, 15.6 something. All right, that's it. Okay. So if you know this triangle and you know those ratios, then that will be immensely helpful to solve this SAT question. Because look, I have a bunch of 30, 60, 90 triangles all scattered throughout this, don't I? Okay, it's all about geometry. Okay. And I like the root 3, but I don't know if on that necessarily. Okay. Well, that's all right. We can still figure this out. All right, so here's one of these 30, 60, 90 triangles. Isn't that true? Okay. Now this hypotenuse is w root 3. Okay. Oh, actually, no, never mind. Okay. So guys, could this be a ratio of 1 to 2 to the root 3? Okay. So let's find this length right here. Let's do that. You guys ready to find this length? I just marked in black. All right. What does that compare to the hypotenuse of that triangle again?
1/2.
Yeah, 1/2.
Yeah.
Isn't this always half of this?
Yes.
Maybe just rotate a little bit. This is half of this. So in terms of W, what should I write?
W.
1/2 W times 3.
Yeah, √3/2 times W, something like that. A little different ways to write that. Right. And if that's true, right, okay, now we know the short side. Now you guys know the short side, right?
Yeah.
Now that you know the short side, what is this medium side equal to? The short side times
X.
the √3.
Yeah.
Right, whatever the short side is, times the √3. Right? Is that okay? Right. Which is going to tell us this side right here, and then we'll be really, really close to solving this. You guys see that? Right. So if the short side is √3/2 times W, and you multiply that by the √3, what does that give you?
2 times
2 W.
Guys, what is √3/2 W times √3? What is √3 times √3?
3.
3. Okay, and then I still have over 2 and I still have W. So, okay. So put it all together. This side right here is equal to what? 3/2 W? 3/2 W. Okay? Right, you guys got that? That good so far? Right. Now, they said the perimeter of the triangle, and they gave us a hard number. 852 centimeters. Okay. So how many of these segments is the perimeter of the triangle? How many segments?
6.
6. 1, 2, 3, 4, 5, 6. Do you guys see that?
Yeah.
Okay. So let's finish this off here. If I have 6 segments of 3/2 W, and to add that up, I get 852. Right, that's centimeters. Sure. Guys, what is 3/2 times 6?
3.
9? You said 9? Yeah. So can I just divide over 9?
Yeah.
W equals whatever this divided by 9 is.
94.67.
Oh, did they do that? Yeah, they did. 94 point something like that. Okay. Right. So okay, there's one last little stumbling block here, which is that this is not a super nice number. So let me look at my key here. Yeah, okay, we did get the answer right. But the last question is, how do you write that to get credit? Okay? Are you guys ready for that?
Yeah.
This is the last question we got to answer this. Is how do you write that to get credit? So the options are you can write 94.67 as a decimal. Right. You only have so many bubbles you can bubble it. I think you get like 5 bubbles or something. So you go 94.67. They would accept that. Okay. Also looking at my answer key, they would also accept 94.66. Okay, so they'll take that too. You would get credit for that. Right. And then there's a third way they'll also accept, which is a fraction. They accept something over what do you guys suppose is the denominator of this fraction they would accept?
9.
It's not 9. Even simpler.
1.
Huh?
Is it 1?
How about there? Right. Hey guys, take this answer. Everybody's got this on the calculator, right? 94.6 something. You guys got that? Okay. Do this. Say times 3. Because whatever number this is no longer going to be a crazy decimal. It's going to be a nice whole number. And then if I were to divide that by 3, that would be equivalent. Okay?
Yeah.
Okay. So 284. Okay. So this, and this are all the same thing. Okay. If you write and bubble in 284/3, you would also get full credit. Okay. All right, guys good? That's good? All right, all right, that's the close of module 1. So that's the first 27 questions. All right, we are halfway through. Are you guys ready to go on to module 2? Okay. So in the middle here, right, reminder, they do give you geometry formulas, right, shapes, angles, Pythagoreans there, volumes. Right, that's all there for you. So if you need those. Right, they tell you, little technical rules. I think last class was, I don't know in your guys' packet, but in a different packet, there was one where there were 2 correct answers. I think you had to like factor a quadratic or something. Okay. Guys, if there's more than one correct answer, should you only list one answer?
Yeah.
Yeah. That's what you do, right? here's another detail I want to hit again with you guys. Okay, suppose the answer to something was 3.5. Could you write 3.5 and get the answer? Yeah, I'm talking about non-multiple choice, of course. Okay. Could you write an improper fraction, 7/2, and also get credit? Yeah, that's okay. Are you allowed to write a mixed fraction? 3.5. Can you do that? No, don't do that. No mixed fractions. Improper's fine. Decimal's fine. No mixed. All right, let's go on. Okay. So back to number 1. So I imagine these questions are going to be back to a little bit easier now, but we're going to find out. Okay. Ooh, we got a graph. I like graphs. All right, so y versus x. I see this diagonal looking graph here. Oh, what's the y-intercept? Y-intercept. Well, here's the y-axis. Does it look like 5 right there?
Yeah.
And the coordinate 0, 5. I like C. Number 1 is C. Are you guys okay with number 1 is C? Okay. If anybody has any questions, just stop me asking me. Number 2, type of store and average number of employees. Okay, so we've got warehouse stores, department stores, and supermarkets. And we've got, 300s, 200s, and 100s, maybe like average number of employees. For a certain region, the table shows the average employees in the year 2016 by type of store. Based on the table, how much greater was the average number of store employees in warehouse than in supermarkets? So here, I'll write this out. Well, the average warehouse has 365 employees. The average supermarket has 130 employees. And they said how much greater? Shouldn't you just subtract? Let's see, what is that? 365 minus 130. I'm getting 235. That should be the answer. That looks like C. Let me confirm. 2. Yeah, 2 is C. You guys got 2 is C? All right, number 3. M and N are parallel. They look parallel, and it's confirmed down here they are parallel. M and N. What's the value of x? Ooh, guys, that angle x, is that the same as this angle down here? Yeah. Right. Is this angle supplementary? A word I can't say, it starts with us, to this angle 33 degrees? Which means that this angle plus 33 add up to what? 180. So what I'm going to do is take 180 degrees, subtract out the 33 degrees, and that will tell me what x is. Degrees, right? So 180, I'm looking at x is 147, and degrees should be 147. That looks like D. Number 3 is D. Number 3 is D. You guys got 3 is D? Number 4. John rents a tent, $11 per day, plus a one-time insurance fee of $10. Which equation represents the cost to rent the tent with the insurance for D days? Okay. I think he only pays the insurance once, doesn't he? Just when he gets the tent. Okay. What did you guys pick for number 4? What did you write?
C.
Okay, yeah, C. Yeah, there you go. You guys wrote C. Okay. So the cost is $11 per day times number of days plus the insurance fee, $10, which is one time. Right? Yeah, C. You guys got 4C? All right, 4C. Number 5. Ooh, we got a right triangle, or I think it's a right triangle. Yeah, it says right triangle. Not necessarily drawn to scale, but it does have a right angle. A is 4, B is 5. What's the value of C? Oh, is that Pythagorean theorem? Can you guys say this hypotenuse is the square root of a squared plus b squared? Because that would be Pythagorean theorem. So I'm going to say square root of 4 squared plus 5 squared. I think the answer is D, isn't it? Is 5D? 5 is D. 5 is D. Are you guys okay with 5 is D? Okay. Okay, number 6. Function g of x is 6x. Oh, it's linear. Slope of 6. For what value of x is g of x 54? Here, I'll go ahead and write this one down. So we got g of x is 6x. Okay. And we're solving for when g of x is 54. What is x? Yeah, there you go. 9. 9. Oh, that was not multiple choice. So let me check. Yeah, they're looking for 9. Look for 9. Okay. One more thing on this one. I'm going to draw you guys a graph. So, x, y. You guys know what that graph looks like? Yeah.
Very steep.
Yeah. Yeah, very steep. Very steep.
What's 5 explains?
Huh?
It was 5D.
Yeah, 5 is D. Yeah. Number 6, the answer is 9. You had to write the number 9. Yeah, so this has a slope of up 6 over 1. Okay. And if you go out to like a value of 9 out here, then where that would cross right here would be up here at 54. So you got the 0.9 comma 54. Okay. All right. So there's a graphical interpretation. All right, number 7, we got f is defined by it's a cubic. Ooh, you don't see too many of those on SAT, but see a few. See why not? We got f of x is 8x cubed plus 4. It's cubics. Don't those look kind of like this? Right, basically. What is f of 2? Okay, so f of 2. So we just plug in 2, right? 8, 2 cubed plus 4. What is 2 cubed?
8.
8 times 8 is
64.
plus 4 is
That's probably
it should be 68. Okay. Oh yeah, you had to write it. Yeah, my answer key is saying 68. 68. Right, number 8.
What was this here?
We got this f of x. What's the y-intercept? Y-intercept. Oh. Yeah, guys, what is y-intercept? Yeah, -2. So 0, -2. That's got to be b, right? Is 8 b? Yeah, 8 is b. 8 is b. Guys, they gave it to you in slope-intercept form. Guys, what's the slope of that line?
Mr. Griffin, what did you say 7 was again?
7.
68.
Yeah, there you go. Right there.
No,
There's 7. Okay. Number 8. Okay. So yeah, they gave you the form y equals mx plus b. The question is, what's this intercept? So the answer is that 0, -2. Okay. Is what if they ask for slope? What's the slope equal to?
1/10.
Yeah, 1/10. Okay. All right. Number 9. Producer creating a video with a length of 70 minutes. So an hour and 10 minutes. Right? Oh.
It won't load. Start coding. Imagine.
The video will consist of segments that are 1 minute long and segments that are 3 minutes long. Which equation represents the situation where x is the number of 1 minute segments and y is the number of 3 minutes? Okay. Let's come up with that ourselves and then we'll put it all together. So we got to get 70 minutes. So I'll put 70 for 70 minutes equal to. We're going to have x segments that are 1 minute each. So is that like 1 times x plus, and then y segments that are 3 minutes each. So 3 minutes per segment times the number of segments here. Okay. And then if you add it, these are all minutes. It has to add up to 70, right? Does it say exactly 70? Yeah, it says 70. This should be the answer. Let me see if I see one like that. 70 equals x plus 3. It looks like D, doesn't it? Make sure it's 9D. Yes, 9 is D. 9 is D. That's D right there. You guys got 9 is D?
Yes.
All right. Number 10. A function f of x is 7x cubed. I'm going to write this down. Yeah, f of x is 7x cubed. Got that. And the xy plane graph of y equals g of x is the result of shifting the graph f of x down 2 units. What's g of x? Right. So g of x is f of x. Okay. Guys, how do you do down 2? Yeah, you just tag on a -2 at the end. Okay. So it should be 7x cubed and then -2, shouldn't it?
Yep.
Okay. All right. That is. Oh, is that D?
Yeah.
10. Yep. 10 is D. 10 is D. They said. Okay. All right. Guys, last thing today. So that's down 2, right? Down 2. Okay. Well, let's cover graph translations because what if they said something else? What if they said h of x is f of x? How about left 2? How can you go left 2? Okay.
X. X plus 2. No, well, yeah, X plus 2.
Guys, how do you do left 2? Yeah. Okay. Guys, you do x plus 2.
Because yeah, it's always out there.
Remember, yeah, it's sort of opposite of intuition. Like vertically, if you subtract, it goes down. If you add, it goes up. Okay. But horizontally, if you add, it actually goes left, and subtract, it goes right. Okay. I still have to do power 3 right here. Okay. Do you guys notice I tagged the plus 2 directly to the x, and then I push it through the function after the fact? That's a horizontal movement. That would be left 2. Okay. All right, we'll pick up there tomorrow.